a beginner's guide to understanding the layers of blockchain technology. If you've looked into cryptocurrencies or blockchain in any way, you've probably come across terms like Layer 1 and Layer 2 protocols. Blockchain technology is a one-of-a-kind mix of several current technologies, cryptography, game theory and so on, with a wide range of possible applications such as cryptocurrencies. Without the oversight of a central authority, distributed ledger technology, DLT, keeps information verified by cryptography among a group of users who agreed through a predetermined network protocol. They make it possible for blockchain networks to exchange value and data between users securely. They must also be extremely scalable to handle increasing users, transactions and other data. Layers were born out of the requirement for scalability concurrent to the preservation of top-notch security. The phrase scaling in blockchain technology refers to an increase in the system throughput rate, which is measured in transactions per second. With the widespread adoption of cryptocurrencies in everyday life, blockchain layers are now required to improve network security, record keeping and other functions. The blockchain is the first layer in a decentralized ecosystem. Layer 2 is a third-party integration used in conjunction with Layer 1 to enhance the number of nodes and, as a result, system throughput. Many Layer 2 blockchain technologies are currently being implemented. They hope to reduce processing times and increase DPS by developing blockchain layers and optimizing Layer 2 scalability. The blockchain trilemma refers to the commonly held notion that, in terms of decentralization, security and scalability, decentralized networks can only provide two of the three benefits at any given time. The CAP theorem states that decentralized data storage, such as blockchain, can only satisfy two of the three guarantees mentioned above simultaneously. This theorem has evolved into the blockchain trilemma in the context of the current distributed networks. The widely held notion is that public blockchain infrastructure must sacrifice security, decentralization or scalability. As a result, the holy grail of blockchain technology is to create a network with impenetrable security over a broadly decentralized network while also handling internet-scale transactional throughput. Before delving into the trilemma's dynamics, let's define scalability, security and decentralization in general terms. The blockchain's scalability refers to its ability to handle a higher volume of transactions. The interplay among scalability, security and decentralization. To settle a transaction, the network must first agree on its validity. As a result, we can show that scalability is inversely proportional to decentralization when security parameters are identical. Now, assuming that two proof-of-work blockchains have the same degree of decentralization and consider security to be the blockchain's hash rate. The confirmation time decreases as the hash rate rises, and scalability rises as security improves. As a result, scalability and security are proportionate with constant decentralization. Due to the increased demand, transaction fees have risen to the point where some people cannot engage with the blockchain. Increased Ethereum fees are an example of the trilemma, as we can see that Ethereum did not scale without sacrificing security or decentralization. The focus of Ethereum was on decentralization and security, with the number of transactions per second being limited, scalability. Similarly, decentralization and security have taken precedence over scalability in Bitcoin. It's no secret that the scalability of blockchains like Bitcoin and Ethereum is currently limited. Therefore, a global community of startups, corporations and technologists is working frantically on Layer 1 and Layer 2 solutions to solve the blockchain trilemma. Layer 1 blockchain networks are designed for speed, security and expansion. Layer 2 refers to technology enhancements and products that can be utilized to expand the scalability of existing blockchain networks. Getting the perfect balance between the two layers might be a game changer for blockchain adoption and the expansion of decentralized networks. Bitcoin is seeking to tackle the problem by adding a layer to the existing blockchain layer. The Layer 2 solutions will bundle numerous transactions together and only query the base layer blockchain once in a while, according to the idea behind scaling solutions. Ethereum is taking a hybrid approach, with sharding scaling the base layer blockchain and the community anticipating several Layer 2 solutions to boost throughput even further. The layered structure of the blockchain architecture. A collection of blocks with transactions in a specific order represents the structure of blockchain technology. Clients request content or data from application servers while browsing the web or utilizing any apps, which is known as the client-server architecture. A peer-to-peer network is a large group of computers that share data. Blockchain is a peer-to-peer network of computers that computes, validates and records transactions in an orderly manner in a shared ledger. A blockchain's data structure is expressed as a linked list of blocks in which transactions are ordered. The data structure of the blockchain consists of two fundamental elements, pointers and a linked list. Pointers are variables that refer to the position of another variable, and a linked list is a list of chained blocks with data and pointers to the previous block. For blockchain systems, a Merkle tree provides security, integrity and irrefutability. To protect the security and integrity of the data contained in blockchain, transactions are digitally signed.